Hello friends, today let us start with further reactions of aldehydes and ketones. We have already seen the addition elimination reaction. Now there are important four reactions left in this aldehydes and ketones. The first reaction is aldol condensation. Many times question have been asked, write a note on aldol condensation. So it is very important reaction for exam. So aldol is derived from two functional groups, that is ALD stands for aldehyde functional group, that is CHO or CO group, and OL stands for alcohol, that is hydroxy group. So in aldol condensation, the compound formed contains two functional group, that is aldehydic group or ketonic group and hydroxy group, that is alcoholic group. So what is aldol condensation? When two molecules of aldehydes or ketones which are having alpha hydrogen atom, when treated with dilute NaOH or KOH, beta hydroxyaldehyde or ketone is formed. This reaction is called aldol condensation. So first we have to understand what is alpha hydrogen atom. You can see in this example I have drawn the structure of acetaldehyde. The C double bond O group is called carbonyl group. The carbon next to C double bond O group is called alpha carbon atom. I have shown by here the carbonyl group, C double bond O group, and the carbon next to C double bond O group is called alpha carbon, and the hydrogen attaches to alpha carbon are called alpha hydrogen atoms. So you can see there are three alpha hydrogen atom and one alpha carbon atom. In the same way, this is the structure of acetone, CH3COCH3. So the carbonyl group is attached to two adjacent carbon atoms. So there are two alpha carbon atoms and six alpha hydrogen atoms. You can see each carbon is attached to three hydrogen atom. Therefore, there are six alpha hydrogen atom and two alpha carbon atom. The central carbon atom is called carbonyl carbon atom. So, aldol condensation, the first important requirement is aldol condensation takes place in aldehyde or ketone which contains alpha hydrogen atom. So, how reaction takes place? In this reaction, alpha carbon of one molecule attaches to carbonyl carbon of another molecule, and alpha hydrogen of one molecule attaches to carbonyl oxygen atom of another molecule. In the example you can see clearly, here are the example. When two molecules of acetaldehyde are reacted with each other in the presence of dilute NaOH or 10% NaOH, in this reaction I have shown by arrow, the alpha hydrogen attaches to oxygen atom of carbonyl group and the alpha carbon attaches to carbonyl carbon, and therefore the compound formed is CH3CHOH CH2CHO. It contains aldehyde group, that is CHO group, and it contains alcoholic group, that is hydroxy group, OH group. The name of this compound is 3-hydroxybutanol. It contains aldehyde group as well as hydroxy alcoholic group, therefore it is called aldol. When this aldol is heated further, elimination of water, that is OH and H eliminates, and butene 1Al, that is crotonaldehyde, is formed. So in the first reaction addition takes place, in the second reaction elimination of water takes place, therefore this reaction is called nucleophilic addition elimination reaction. So very important reaction for the exam. The point to remember is aldol condensation takes place in aldehyde or ketone which contains alpha hydrogen atom. The second reaction is Cannizzaro reaction. When an aldehyde or ketone which does not contain alpha hydrogen atom is heated with concentrated NH or KOH, this reaction is called Cannizzaro reaction. In this reaction, a mixture of alcohol and sodium salt of carboxylic acid is formed. It is self-redox reaction or also called disproportionate reaction. Why it is called self-redox? Because two molecules of aldehyde react in such a way that one molecule undergoes reduction and another molecule undergoes oxidation, and therefore this reaction is called redox reaction. For example, this is the structure of formaldehyde. It contains the carbonyl group does not contain any further carbon atom, therefore it does not contain alpha carbon atom. Or in the benzaldehyde structure, the carbonyl group is attached to benzene ring carbon atom, but this benzene ring does not contain any alpha hydrogen atom, and therefore Cannizzaro reaction takes place in aldehyde or ketone which does not contain alpha hydrogen atom. It is purely opposite to aldol condensation. Now, reaction is Cannizzaro reaction. When two molecules of formaldehyde are reacted with 50% concentrated NaOH, redox reaction takes place. One molecule undergoes reduction, that is addition of hydrogen takes place and methanol is formed. Another molecule undergoes oxidation, that is addition of oxygen takes place and sodium formate or sodium salt of formic acid is formed. And therefore, this reaction is called Cannizzaro reaction. The second example of Cannizzaro reaction is when two molecules of benzaldehyde are reacted with concentrated NaOH. One molecule undergoes reduction and benzyl alcohol is formed. Another molecule undergoes oxidation and sodium benzoate is formed. We have seen already in our 11th chemistry chapter redox reactions. Addition of hydrogen is called reduction and addition of oxygen is called oxidation. In this reaction, both processes take place. One molecule undergoes reduction and one molecule undergoes oxidation, and therefore this reaction is called redox reaction or self-redox reaction. It is also called disproportionate reaction. Now, the point to remember is in aldol condensation, aldol condensation takes place in aldehyde or ketone which contains alpha hydrogen atom, whereas Cannizzaro reaction takes place in aldehyde or ketone which does not contain alpha hydrogen atom. The second point must be important to remember is aldol condensation requires dilute NaOH or KOH or 10% NaOH or KOH, whereas Cannizzaro reaction requires 50% NaOH or KOH. Now, third reaction is Clemenson's reduction reaction. In Clemenson's reduction reaction, carbonyl group, CO group is converted into CH2 group, that is methylene group. That is, aldehydes or ketones are converted into alkane by reduction process. So, for this reduction, zinc and mercury in HCl is used. It is also called zinc amalgam in HCl. In the example, you can see when acetaldehyde is reacted with 4 nascent hydrogen, these 4 nascent hydrogen came from zinc amalgam in HCl. The C double bond O group is converted into CH2 group, and there is one more hydrogen, so I have written CH3 single bond CH3 plus H2O. In the same way, when acetone is reacted with 4 nascent hydrogen in the presence of zinc amalgam in HCl, C double bond O group is converted into CH2 group, and therefore CH3 CH2 CH3 propane is formed. So, importance of Clemenson's reduction is, by Clemenson reduction reaction, aldehydes or ketones are converted into alkanes. This reaction we have seen in 11th hydrocarbon chapter. Now, next and last reaction of aldehyde and ketone is Wolff-Kishner reaction. In the Wolff-Kishner reaction also, aldehydes or ketones are converted into alkane. But the method is, first the carbonyl group is reacted with hydrazine to form hydrazone. We have seen this reaction already. Hydrazine is NH2 single bond NH2. When aldehyde or ketone is reacted with hydrazine, hydrazone is formed. That is, elimination of H2O takes place, and N single bond NH2 group is formed. When this hydrazone is further reacted with NaOH or KOH or ethylene glycol, this both nitrogen gets eliminated in the form of nitrogen gas, and RCH2R, that is alkane, is formed. In the example you can see when acetaldehyde is reacted with hydrazine. First it gives acetaldehyde, hydrazone, and H2 molecule is removed. And in the second reaction, when acetaldehyde hydrazone is reacted with KOH or ethylene glycol, ethane is formed with elimination of nitrogen gas. So this reaction is called Wolff-Kishner reaction. The important point to remember is Clemmensen reaction and Wolff-Kishner reduction reaction, they both forms alkane. That is, carbonyl group is converted into methylene group, that is, alkane is formed. But in the Clemmensen reaction, nascent hydrogen is used, and for nascent hydrogen, zinc amalgam in HCl is used, whereas in Wolff-Kishner reaction, hydrazine is used, and this hydrazine is converted into hydrazone, and hydrazone is reacted with KOH or ethylene glycol or NaOH, and nitrogen gas gets eliminated and ethane is formed. So here we will conclude the chemical reactions of aldehydes and ketone. In the next lecture we will see the chemical reactions of carboxylic acid.